Hey everybody, welcome to this video. So today we're going to talk about how we can use binary numbers to generate rhythmic patterns. This is building upon some of the work that we've already been doing, experimenting with sequencing devices in MSP. And today we're going to focus sort of narrowly on just the question of pattern generation. Basically, how do we generate sequences of gates and rests? And one interesting way to do that generatively is to use binary numbers. As most of you know, numbers can be represented in many ways. We can represent them just like this, 89, and this is what's called the decimal number system, where each column that we have is a different power of 10. So to actually calculate this, you would say it's 9 times 10 to the power of 0, which is 9, plus 8 times 10 to the power of 1, which is 10. So that's 8 plus 9, or 80 plus 9 is 89. This is the same number, actually. This is 89, but it's represented as a binary number in the base 2 counting system, where each column is a different power of 2. So to calculate what this number is, we would go, it's 1 times 2 to the power of 0. 2 to the power of 0 is 1, so that's 1 times 1 is 1. 0 times 2 to the power of 1 is 0. 0 times 2 to the power of 2, 1 times 2 to the power of 3, etc. If we add all those numbers up, we're going to get 89. What's really cool about this is by taking just any simple number, we can end up with all these different patterns that we can use as rhythms in our music. So let's do that. So first I'm going to talk about once we have this pattern, we can actually output it and send it to, say, a MIDI synthesizer or any other device that we're using to generate sounds. So we're going to use an object that we've seen in the past, which is called stash, with the mode attribute set to 1. Okay, and I'm just going to create kind of an arbitrary sequence here. And what we'll eventually be doing is generating that sequence from a number. You'll notice if I try to connect a message box directly into the output of this number box that's showing the number in binary format, we don't actually get it that way because this is still an integer as far as max is concerned. We need to actually get a list. So a lot of the work that we're going to be doing in this video is basically figuring out, okay, how do we turn this integer into a list that looks basically exactly the same, but has spaces in there, and then can be used by the rest of our system. But first, let's talk about how that system actually works. So the stash object, as we discussed in the last video, is capable of storing a bunch of values and then basically recalling them. So I'm going to set it up in the most simple way possible to start, where I have the sequence being passed into the first inlet, and then into the third inlet, I am able to pass an index. And whatever number I pass, it's going to return the corresponding number in the sequence. Now, I'm not getting what I expected to. Why is that? Let's check. There we go. So you can see that the 0th number in the sequence is 1, which is this first one. The 1th, as we might say, or the second number in the sequence is 0, and so on and so forth. So we can automate this by using a phaser, which is something we also looked at in the last video. And it's convenient to use it in conjunction with transport object. And we can visualize that phaser with a scope object. Cool. So it looks like transport's already running, but if I were to stop it, I could stop it. Great. And then I'm going to go over here and actually grab a little snippet that I already have. Which is going to format for us this the number of steps. It's going to basically, first we're going to calculate the number of steps in this sequence. And then we're going to pass that information on as a list that is formatted for consumption by the what tilde object, which looks like this. And if you're confused about what's happening here, go check out that other video, which explains just how this works. But basically what it is going to allow us to do is create, in this case, 8 pulses over the course of this phaser's ramp from 0 to 1. So you can see we have these pulses. And then what we'll do is add those up. And the result that we're going to get is basically going to be a running count of those pulses. We'll subtract 1 because our stash wants us to start counting from 0, and then we can pass that into stash. And now you can see that we're actually playing back this sequence that we have stored here. So I'm going to take this away, and I'll clean this up just a little bit. We'll call this our counter. And we'll call this our cool. So now anytime we have a sequence, we want to pass it both into this abstraction, or sorry, this subpatcher here, and into the stash, because it will, with the ZL-len object here, calculate the length, the number of items basically in that sequence, and then set up what to generate a an output every time to count out those events. So now we can actually basically play out this sequence over the course of this ramp from 0 to 1. Okay, so now that we have that, now let's get to the interesting part, which is generating the binary sequence just from a single number. So, as we said, this number is composed of powers of 2. And so what we're going to want to do, actually, before we even begin starting to process this, is decide how long do we want our sequence to be. Because as you can see here, when we have 150, or let's do something a little easier, like 5, there's 3 digits in the binary number. If I go up to, 12, it's 4 digits now. But if we wanted to, we could just add a bunch of zeros to the beginning of this and it would be the same number. So we're going to add another number box that basically allows us to like append a bunch of zeros to the beginning. So let's say maybe 16 of those, or 16 total, so 12 zeros ahead of this. Okay, and we're going to create an Uzi. And we're going to pass that value into the Uzi. And then we are going to subtract the Uzi's left output, or I'm sorry, the right output rather, from that number of steps, which is basically just going to cause the Uzi to count backwards. Because the right output of Uzi is going to output, when I bang it, it's going to output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So doing this, subtracting that value from 16 is going to have us count from 15 downwards, which is what, in this case, we want. And then we're going to take that number and we're going to raise 2 to the power of that number. And I will print the output here just so you can see what happens. We're not actually doing anything with this seed number yet, but you can see now we're getting 16 values, and we're getting that each of those numbers raised to the power of 2. I'm sorry, 2 raised to the power of that number, starting from 15 and going all the way down to 0. Great. And so then what we're going to do is store the seed value, and then we will divide it by, we'll divide the number, this raised to the 2 raised to the power of n number, by our seed number, which is going to give us something that looks like this. Okay. And then, in fact, actually, we're going to do integer division, which is going to give us integer results, as you can see here. And then we're going to take the modulus of 2, which is basically going to tell us if the number is even or odd. And so now you can see we have a sequence of zeros and ones, and you can already see that we have the number 12 because we have 12 zeros, 2 ones, and now 2 zeros. So now all we need to do is group these together. And then pass them into our stash and into our counter. And we can visualize them as well. And let's just encapsulate this really quickly. And I'm confused. We have something going on here that's weird. Ah, I see. Cool. We don't need that. Let's get this out of the way. And then we don't really need this anymore. We'll drag this over here. And we would like to see what that pattern is. So now if we change this number to 57, then we're going to get a pattern that looks like this. So a lot of zeros. If we go up to like maybe a bigger number, so let's say like, 479. And literally all we need to do now is say if the output of our stash changes. In fact, actually, that's not what we want. If the output of our counter changes, then multiply that by the value of our stash. Because with a change object, we get a very convenient little pulse each time the value changes. And we're then going to multiply that by the value that our stash produces, which is either 0 or 1, which will basically erase the stashes that are zeros, the stash values that are zeros. And we actually want to take the absolute value of change because the change output will sometimes be -1. And then we're just going to pass that into an edge tilde. And then we're going to pass that into our MIDI generator. And now we have a binary pattern sequencer. So if I say change this number, I can change the pattern. So this becomes a really, really easy way to just get literally any pattern. You can literally get any pattern of zeros and ones with just these two numbers. And that's it. One useful thing that you may want to do, just to give yourself a little bit more control, is just throw a ZL rotate in, or a ZL rot. And then we can pass another integer into that, and that will just, we have to first fill it, and then we can, we need a TBI here, of course, TBI. We can actually rotate that pattern. So all we're doing is just shifting it left to right. So if I start from 0 and then I go to 1, I'm just nudging things over. So that's kind of another cool way to get it to just modify that pattern slightly. And just for one final piece of fun, a thing that we could do here is each time that the counter resets, so if we come in here, we already have, actually not there, but where? Here. This, what on the left, is going to give us a little impulse every time the bar resets. So maybe what we would actually want to do is just increment this rotation value and just move that over each time. So you can see here, every time we get a bar, oops, we get a little impulse. So what we can do is use an edge again just to turn that into a bang, because we don't really need it to be a signal anymore. And then we'll trigger a 1 integer. And we'll pass the out. We will pass the value into the middle inlet of an accumulate object, and then we just need to bang it. And so now, each time that the pattern is played back, it's shifted, which is kind of cool. And so this is really sort of a building block, you could say, of like a generative music making system. I will post the patch here in the description to the video. Have a great day.